So for this assignment, we're converting a pyruvate molecule to acetyl CoA. This is the pyruvate molecule. And we're going to start off with the pyruvate dehydrogenase complex, which contains E1, E2, and E3. So the pyruvate molecule begins the process with interacting with TTP, which is thiamine pyrophosphate. And the TTP is responsible for getting rid of the CO2 molecule that's on the pyruvate acid, which is right here. So we're going to go ahead and get rid of CO2. And at the same time, the TTP molecule is going to form into a hydroxyethyl TTP, which looks like this. So now the CO2 is gone and the pyruvate molecule is attached to this, the hydroxyethyl TTP. And this was in the E1 step. So moving on to E2. E2 is the dihydrolipoyl transacetylase. And this contains a cofactor called lipoic acid, which is right here where the sulfurs are. And it allows for an easy reduction of these sulfurs, and it transfers acetyl groups. So now we transfer the hydroxyethyl group to one of the sulfurs. And this will form the group that's attached. So this is the reduced sulfur right here, and this is the acetyl group. So now this group comes over to CoA, and they will both form acetyl CoA. So that comes over here. And this will form and this is formed because the sulfur from the lipoic acid will take the acetyl group, or the sulfur from this molecule in E2 will take the acetyl group in the lipoic acid, and it will form acetyl CoA. So this is not bound to any membrane or any molecule, so this is just floating freely, and that's how you get an acetyl group from pyruvate.